Welcome to another episode of WaveFEA tutorials. This is your host Pat, and today we're going to talk about the method to set up non-linear static analysis for large displacements. Linear static analysis works well with small displacements. However, if the structural displacements are larger than the allowed limit, it creates a problem. This can be solved using non-linear solution sequence. While talking about large deflections, we are referring to translations or rotations of the part. For an instance, if you expect a part to rotate or deflect by 45 degrees, then a non-linear analysis would be required. And also, non-linearity has to be used if contacts and follower forces are present. Let's now jump right into the tutorials. The model used here is a plate rolling over the cylindrical roller. The cylindrical roller serves as a stopper, which is in contact with the plate. Let's now set the units to English, which in turn will set itself to pounds, inches and seconds. The material for the plate and the stopper can be set by clicking on the material button on the command manager. Choose aluminum alloy for the plate and steel for the stopper. The idealizations can now be defined. This can be done by clicking on the idealizations button on the command manager, checking off the associated geometry option for manually selecting the plate material, and make sure that aluminum is selected. Similarly, the idealizations for stopper can be defined by selecting the material as AISI carbon steel. Right-click on the mesh model and convert the settings to a table, and then generate the mesh. Now that the mesh has been generated, the boundary conditions can be defined. This is done by clicking on the Constraints button on the command manager, changing the default name to Plate Face Fixed, and manually selecting the face of the plate in order to fix the face in all the translations, allowing it to freely rotate in all the directions. Similarly, a new constraint has to be created for the stopper. This can be done by clicking on the new button in the Constraints dialog and changing the default name to Stop Fixed. Select the bottom face of the stopper to constrain the stopper in all the translations and rotations. In order to define the contacts for the model, click on the Manual Contact button on the command manager. Set the mode to manual in order to select the master and slave entities manually. Let's now set the analysis type to non-linear static analysis. This is done by right-clicking on the analysis one, selecting the type to non-linear static and ensuring that the large displacement is set as on under the Options tab. In order to view the intermediate results, right-click on the non-linear setup one in the analysis tree under the subcases, define the number of increments and set the intermediate output to all. The loading conditions can now be defined by right-clicking on the load and selecting the extreme end face of the plate and setting the FY tab to -200. To cross-check the load by visualization, let's increase the density of the load. As all the prerequisites are defined, we can run the analysis in Nastran. The analysis progression can be seen on the screen. To view the results, right-click and edit the results in the browser tree, select the last increment under the Subcases tab, ensure that the solid von Mises stress is selected under the result type, and finally, click Display under the Plot section. We can now observe the maximum and minimum values of the analysis which are being highlighted. In this tutorial, we have learned the ways to set up nonlinear analysis and define surface contacts. Thank you so much for joining us today. This is your host Max signing off. For more information, visit our website www.wavefea.com. You can also opt for a 30-day free trial of WaveFEA software by registering with us. We will be back soon with more features and updates from WaveFEA team. Thank you.